I will start from the fundamental just to revise because you already know the basics, but तब भी मन लगा के पढ़ो, क्योंकि अगर भाई आपको आता भी है तो भी आपको ध्यान से पढ़ना है. ओके, so let us start it from complex numbers. Okay, so the idea of number itself, the idea of number is from counting. Okay, जो भी हिस्ट्री है नंबर की, that idea comes from counting. Our understanding of numbers is from counting. And you know, the way we write numbers, that tells the complete story. For example, when we write 1, so it is just, you know, counting 1. Something is equal to 1. When we write 2, so it is like this, and then, you know, it developed like this. Okay, we write 2 like this. Okay, उसके बाद धीरे धीरे करके मॉडिफाई होता जाता है हिस्ट्री में. When we say 3, it is actually like this. So there are, you know, historical developments of numbers. So the why I am telling you this is that our understanding of numbers is because of counting. Okay, now when the idea of you know, negative numbers comes, so you have to extend this idea of counting. I mean, counting numbers are from 0, 1, 2, 3. These are counting numbers. When one negative numbers comes, you have to little bit extend the idea. Then आपने negative numbers को भी accommodate कर लिया अपने number family में. Okay, so first of all, these type of counting numbers are there, then negative numbers are there. Okay, negative numbers, but still we understand the negative number. For example, if your balance, your bank balance is minus 1000 rupees, so you understand what is meaning of that. Yes or no? In terms of counting, you understand that what does it mean. And if it is plus 1000 rupees, then also you know whole idea of debit and credit is positive and negative. So we understand these positive and negative numbers in terms of counting. Okay, now on the other hand, and then you know, the number between 1 and 2, the numbers between 1 and half. So for all those things we have all different class of numbers. Okay, rational numbers, irrational number, etc, etc, that all we understand. But then comes a number like this. Suppose there is an equation, x square plus 1 is equal to 0. Okay, and equation is like this, and obviously before this, suppose there is an equation like this, x square minus 1 is equal to 0. So if the equation is like this, we know that the factorization gives you like this. Yes, a plus b, a minus b, and so either this is 0 or this is 0, so the value of x is minus 1 and plus 1. Am I correct? Now when an equation like this comes, you have, and you know what is meaning of this x square is equal to 1? That means if I multiply minus 1 into minus 1, I will get 1. And if I multiply 1 into 1, then also I will get 1. That is the definition of square. Okay, so I was telling you that under root of negative 1 was actually new concept. अब इसका काउंटिंग, अभी तक की काउंटिंग में हमारी कोई, we don't have any understanding about this under root of minus 1. Okay, and because it does not belong to a family of this numbers, counting numbers, so at that point of time people gave it, like they thought that this is real word, and by the analogy they gave this a name which is iota. Just a name like this, I for imaginary. So this I became under root of minus 1. Okay, and this is just a notation. Okay, this was just a notation, and the problem of doing the algebra was resolved, because if I now write x square plus 1 is equal to 0, and now the roots are x is equal to iota and minus iota. Okay, the roots are iota and minus iota. Okay, so now we can factorize this also. I can make the factors also using this. So this was actually not a good name. The imaginary word, उससे हमें थोड़ी दूसरी feeling आती है. But this is also a number. This is just another kind of number. So it is not necessary that every number has to be understood in terms of counting, na? So it was just another class of numbers. It was just another class of numbers, and this was called imaginary numbers. So now any number multiplied by this will be imaginary number. For example, 2i, 3i, 4i, okay, like that, or minus 2i. So negative will also follow this. This will become the imaginary numbers. Okay, इनको क्या कहा गया? They were called imaginary numbers. Just by chance this name was given, and otherwise nothing special about this name. Okay, just another class of numbers. Okay, now jahan pe bhi under root of minus this, because under root was very common mathematics that was used, and obvious tha ki kisi na kisi point of time pe kisi na kisi ko dekhna hi tha कि ऐसी algebraic equations के कैसे solution होंगे. So they found that it is in the form of some different class of numbers, and that number was called as imaginary numbers. Okay, and Gauss used this concept to explain the factorization. So जैसे अगर आप किसी क्लास 7th के बच्चे को कहो कि what is x square minus a square, so he can tell immediately that it is x plus a, x minus a. Okay, ये बोलेगा. And if you ask what is x square plus a square, so हम जब क्लास 7th में होते हैं तो we think that this cannot be factorized. So if you want to factorize this, how you will think? The obvious method will be that इसको किसी तरह से ऐसे लिख लें, to write it as x square minus minus of a square, na? Yes?
Yes, sir.
And to take this negative sign inside, the obvious way will be x square minus. If I want to take negative inside, what is the method? I will write it like this: iota a whole square, because iota square is minus 1. Yes? So I need a number जिसका square minus 1 हो जाए ना. That is the thing. So it will go inside and it will become like this. So now if you open this, it will become x plus iota a and x minus iota a. अब आज की डेट में आपको ये बड़ा सिंपल लग रहा होगा, बट पहली बार इसको किसने किया था? गॉस ने किया था. none other than गॉस. और आपको पता है गॉस इज लाइक, किसी भी मैथमेटिशियन को उठा लो, उसके गाइड पे चलते चले जाओगे, वो गॉस पे जाके खत्म होगा. ओके, he was advisor of Riemann, so you can understand. So how fundamental is this thing and how important is this? So पहला एप्लीकेशन आपके सामने आ गया कॉम्प्लेक्स नंबर का. व्हाट इज दैट? Factorization. Factorization is not a small thing. So the first application of this came in front of you, and that is factorization. Okay, you understood the origin? So now let us just proceed our discussion. So the fundamental is that iota is equal to under root of -1 and iota square is equal to -1. Yes, iota square is equal to -1. This is the fundamental, and using this we will see how complete mathematics was formed. Okay, now the most important step that I consider was given by Argand. मैं एरगेंट के कंट्रीब्यूशन को बहुत 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 ज्यादा इंपॉर्टेंट मानता हूं. आई विल एक्सप्लेन यू व्हाई. बिकॉज the concept given by Argand was that the real number and imaginary number, they are like basis. And you know what is the meaning of basis? जैसे वेक्टर्स होते हैं आई जे, आई कैप, जे कैप. So the role of I cap cannot be done by J cap. The role of J cap cannot be done by I cap. Is that correct? If suppose
Yes,
there is a vector in which I cap is absent and there is a vector in which I cap is present, so you cannot write this vector in terms of that vector. They are linearly independent. Okay, that is the meaning of basis. इसीलिए आपको तीन एक्सिसेस की जरूरत पड़ती है because तीनों linearly independent है. You cannot replace the role of one by the other by multiplying it with any number. Okay, so Argand realized that these numbers, real and imaginary numbers, they are just acting like the vectors. So what will immediately come to your mind? कि ऐसा करते हैं, if they are behaving like mutually independent things, so एक को मैं real axis कह देता हूं, yes, और दूसरे को मैं imaginary axis कह देता हूं. आप देखो जरा कितनी simplicity आ गई. So because of the introduction of iota, your general number became like this, x plus iota y, because now iota is also there. Okay, and this number is known as complex number. This number is known as complex number because it has got real part also, it has got imaginary part also. So this is not an imaginary number. If it was only iota y, then it was imaginary number. If it was only x, and I must also tell you, sorry, बीच में रुक रहा हूं, these are element of real number set. X comma y are element of real number set. So if it is only x, it is real. If it is only iota y, it is imaginary. But if both, then it is known as complex number. So obviously it is so simple. I mean, abhi simple lag raha hai, but the role of Argand is so important because it connects this complex number to the whole world known to us. Argand ने जैसे इस प्लेन पे इस नंबर को पुट किया, बाकी की मैथमेटिक्स अपने आप डेवलप होती चली जाएगी because we already knew all that. See how if I put a point here and I can represent this as x comma y or not. अगर मुझे पता है कि this is real part, this is imaginary part, I can just put as x comma y. We know that this is imaginary axis. Yes. So only simple notation is this: z x comma y. Your point is this. You have represented it like this. Now just join it with this origin. यहाँ पे draw कर दो. This one is what? X. And what is this? Y. This angle is theta. This is R. Okay. Now you see, by our conventional knowledge, X will become R cos theta or not? Y will become R sin theta. Yes. It will become R cos theta plus iota sin theta for, and this is called polar form. Polar form. अब ये इंपॉर्टेंट इसलिए है कि 99% of complex is used because of sine and cos. 99%. Why iota appears in your quantum mechanics, why it appears in your electromagnetic theory, why it appears in your normal mathematics in solid state. Why iota? From where iota is coming? Because there is sine and cos and we can have a relation. That's why iota is appearing. Let us see how we can form a relation. So एक तो इसको square bracket में रख लो. Z is equal to r cos theta plus I sin theta. Now let me quickly give you from where this is coming. Okay, so what is e to the power x? 1 plus x square by 2 factorial plus dash dash dash. What is cos of x? This is 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial minus dash dash dash. Correct? What is sine of x? It is x minus x cube by 3 factorial plus x to the power 5 by 5 factorial minus dash dash dash. Now what is e to the power iota x? See from here, it will become 1 plus iota x whole square by 2 factorial plus dash dash dash. Correct? And if you write it separately, it will become 1 minus x square by 2 factorial plus dash 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 plus iota x minus x cube by 3 factorial plus dash dash dash. Correct? Let me write the third one also. And this will become cos of x plus iota sine of x. What we can write for z in compact form? Z will become r e to the power I theta. Yes? And e to the power I theta will become cos theta plus iota sine theta. And this equation is known as Euler's equation. So in 17th century. So you know, Euler was like, when he was alive, he was supposed to be the greatest the most intelligent mathematician on the planet. इस तरीके से उनको लोग जानते थे. तो you can understand कि ये derivation अगर कितना important होगा जो अभी मैंने फट से कर दिया. हाँ? And हम लोग उतने में ही महान हैं कि अगर हम इन लोगों के काम को समझ सकें. क्यों? So you know, this Euler's equation is such a powerful equation. इसकी इंपॉर्टेंस को बताने के लिए एक छोटी सी मैं आपको स्टोरी सुनाता हूं कि एक बार एक जर्नल है. देयर इज अ जर्नल कॉल्ड फिजिकल रिव्यू लेटर्स. दैट इज वेरी वेरी इंपॉर्टेंट जर्नल. और उसमें पेपर होना मतलब एक गर्व की बात होती है. इट्स अ मैटर ऑफ प्राइड टू हैव पेपर इन दैट जर्नल. एंड उसमें एक वोटिंग हुई कि विच equation you consider the greatest equation up to this century, since 100 years or more than that. In that voting, Einstein's equations were there, de Broglie's equations were there, Maxwell's equations of electromagnetics were there, but people selected Euler's equation because those who have studied higher mathematics and higher physics understand that without Euler's equation you can't do anything. You can't do quantum mechanical calculations without Euler's equation. You can see iota in Schrodinger equation. From where that is coming? That is coming from Euler's equation. Okay? Yes? So let me. So इतना समझ आ गया सबको? So this Euler's equation opens door for so many things, and I want to tell you, जितनी जगह आप आयोटा देख रहे हो, that is because of Euler's equation. 99%. So you know, z became r e to the power I theta. Yes? And if I want real of z will be r cos theta. Okay? Because z is r cos theta plus iota sin theta. So if you call real part, only r cos theta will come. And if you call imaginary part of z, r sin theta will come. Okay? We can also write this z as in the form of cos theta and sin theta like this. Cos theta is equal to 1 upon 2. So you know, if I want, if I write, so पहले तो ये इतना समझ लो. If I write Euler's equation as this, e to the power I theta is equal to cos theta plus iota sin theta. E to the power minus I theta will become cos theta minus I sin theta. So cos theta will become 1 by 2 e to the power I theta plus e to the power minus I theta. And sin theta will become 1 upon 2 iota e to the power I theta minus e to the power minus I theta. Okay? So these are two very, very important formulae that we will be using. And in this way, if e to the power I theta is cos theta plus sin I sin theta by Euler's equation, I can write real of e to the power I theta will be cos theta. Yes? And imaginary of e to the power I theta will be sin theta. Bolo bhai. So these are just some basics that I wanted to revise. You already know all that. But actually iota will not play any role, because you know that is not a number that can be counted, na? That is just a different class of numbers. So we will be using that, but unka actual matlab nahi hoga. Let me give you an example of that. Just let me give you a simple example to understand how that comes into picture. Okay? So suppose I want integral of cos theta d theta. Please see this. Just to explain you, okay? I want integral of this, so I will write integral of e to the power I theta d theta, and here real part. Can I write this? Because I told you cos theta is equal to real of this, so that will become real of, what is integral of this? E to the power I theta by I. Iota will be just treated like a number. Iota का treatment कैसे होगा? Just like a number, constant number, because it is a number. So this will become, yes, real of cos theta plus iota sin theta by iota. So real of minus I cos theta plus sin theta, which is equal to sin theta. समझ आया? और अगर इसमें एक के साथ एक फ्री मिलता है, एंड दैट इज वन ऑफ द वेरी इंपॉर्टेंट एप्लीकेशंस ऑफ कॉम्प्लेक्स नंबर. ये अभी आपको इतने छोटे से स्टेप में समझ नहीं आता, बट कई प्रोग्रामिंग कोड्स होते हैं. देयर आर सम प्रोग्रामिंग कोड, सपोज दे विल रन फॉर 25 days and you want result for a odd function and even function to see the behavior. So if you replace it by e to the power I theta, you have got both at the same time. Real part will represent this, and suppose you had integral sin theta d theta. So ऐसे ही आते, यहाँ पे imaginary आ जाता. So you have got imaginary of this, which is minus cos theta. See that? So ये बड़ा ही simple example है, but I like this example just to understand how this iota thing is playing. कहीं भी iota का use नहीं किया, but result निकाल लिए. You have not used iota anywhere, but you got the result. Yes? Let me take another example. ये तो आपको पता ही था, sin theta cos theta. But ऐसा मत सोचना कि ऐसे ही इंटीग्रेशंस निकलते हैं. Suppose you want to integrate e to the power ax sin bx or cos bx. ये दो इंटीग्रेशंस है. I am telling you, they are very, very important for Fourier series, for Laplace transform, for Fourier transform, and for complex, and for quantum. Doing this integration by some other method is very, very difficult, because you know this will not finish e to the power ax, है ना? So a simple way is to just write e to the power ax e to the power iota bx dx. समझ आया? And it will become e to the power a plus iota b x dx, and it will become integral is so simple, e to the power a plus ib x over a plus ib, and it will become e to the power ax by a square plus b square into e to the power ibx a minus ib. समझ आ रहा है? E to the power ax upon a square plus b square. See this, cos bx plus I sin bx a minus ib. Okay? Now write the answers for this. साइन वाले का आंसर क्या होगा? इसका कौन सा पार्ट? इमेजिनरी पार्ट. इसका आंसर क्या होगा? रियल पार्ट ऑफ दिस. सो राइट बोथ. इसका आंसर क्या होगा? e to the power ax over a square plus b square. Just write the imaginary part. What will be the imaginary part? A sin bx and minus b cos bx. This is imaginary part. And what about this? E to the power ax upon a square plus b square. Tell me the real part. A cos bx. And what about this? Plus b sin bx.